Complete the following statements to be true. The limit of f as x approaches 3 from the left side is -1. As x approaches 3 from the left side, meaning that over here we write 3 and on top of it we write minus sign. From the left side means negative sign. Is -1. So over here we write is equal to -1. To check this on the graph, we can go to where x is equal to 3. So there is this. And we can draw a line over it. From the left side is -1. From the left side means where the graph is pointing towards the left side, which is this one because it's going to the left side is -1. So when we draw a line to the left side, we find -1 here. So this is how you check if it is true or not. So this statement is true. The limit of f as x approaches 3 from the right side is 2. We can write this in limit notation by writing 3 over here. When it says the limit of f as x approaches 3, there should be 3 over here. From the right side means that it should be positive sign on top of 3 is 2. So this is equal to 2. We can check this on the graph by going on the line on x is equal to 3 and finding the graph where it goes to the right side. So we have it here. And we can see that the y value is 2. So this statement is also true or correct. If the two sides are different, then the limit of f as x approaches 3, we don't write plus or minus here because we're talking about both sides. And if these two numbers are not equal to each other, then the limit does not exist, which is d and e does not exist. So if the left and right sides are not equal to each other, then the limit does not exist. Write the limit notation of each of the following statements. The statement the limit of f as x approaches 4 from the left side is true. So first we write lim, which stands for limit of f as x approaches. So we write f and then in bracket we write x, and then as x approaches 4 from the left side, which means that under lim we write x and then we draw an arrow sign which points to the right side, and then we write 4 as it says approaches 4. Approaches means arrow sign, and from the left side, which basically means negative sign on top of 4. If it was right, then it would be positive sign. Is 2, which means is equal to 2. If we check this on the graph, we have to go to where x is equal to 4. So this is our function. And we find a removable discontinuity over here where y is equal to 2. And we are going to the left side because we're checking from the left side, and y is equal to 2. So this statement is correct. The limit of f as x approaches 4 from the right side. So again, it's the same graph and it's moving to the left to the right side, and it is also equal to 2. So we write the same exact thing we wrote over here, but instead of writing minus, we write plus. So lim f of x as x approaches 4 from the right, plus because it says from the right, and the right side means positive values. Since this is a removable discontinuity or hole, It exists, meaning the limit exists because both of the values are equal to each other. 2 is equal to 2. So if the two sides are the same, then the limit of f as x approaches 4 is equal to 2 and it exists. But we don't write plus or minus when we write as x approaches 4 because we're talking about both sides, left and right. Write the limit notation of each of the following statements. The statement: the limit of f as x approaches 1 from the left side is -1. The limit notation: we write lim f in bracket x, which is basically the limit of f as x approaches 1 would be x, then arrow, and then 1 from the left side is negative symbol is -1, so it's equal to -1. On the graph, we can check this by going to x where it equals 1, so it's over here because it's right over here. As it approaches 1 from the left, so this is the graph that goes to the left side, and here is the removable, here is the discontinuity because it's going to the left side, and the y value is equal to -1. So this is correct because it says is -1. The limit of f as x approaches 1 from the right side is 0. We write the same statement as above, but instead of writing negative sign above 1, we write positive sign because it's talking about the right. So we go to the same line and we check for the limit as it approaches the right side, which is this one. And over here, the value of y is 0. So the statement is correct. If the two sides are different, meaning that if the numbers for both of the equations are different to each other, which they are because -1 is not equal to 0. So limit of f as x approaches 1, we don't write plus or minus because we are talking about both sides, the left and the right, does not exist because from the left and right side there are different values.